Hello everyone, I am Tanmay and I'm going to show you how to use the pre-built graphing container images to generate your own plots from the JSON samples collected by the container profiler. Now the container profiler would store the collected JSON samples in the output directory you mentioned. So if you mention something like the new JSON test here, you'll have that directory filled with all the JSON samples collected by the container profiler while benchmarking your provided process or application or workflow. And if you try to see inside the directory that was provided as the output, you will see a bunch of JSON files like this, and each of them have a bunch of CPU data, memory data, with different verbosity levels of containers, of VMs, and processes. And to get a better idea of what things are going on inside this, you need to plot these things, and you can do that by using the plotting libraries here, which have been provided inside the repository. Now, these libraries have a lot of dependencies which you'll need to install. So you have the PIP, you need Python 3 there. I don't think you need Python 2 anymore, but you still need Python 3 to be installed on the system. And you also need Miniconda and everything, Pandas, Plotly, Matplotlib, NPM, Electron, Orca, and a bunch of other things. But if you want to go this path, feel free to. It might be a little bit of effort, but it will save you some space on the disk. But if you want to keep it simple, you can use the pre-built graphing image, which I have already built and posted on Docker Hub. The image name, the repository on the Docker Hub is the Tanmay UW CP graphing, and the image tag is minimal. The image with the tag minimal has been optimized a little bit, so its size is around 2.5 gigs. If you go for the full CP graphing latest image, that image is around 3.8 gigs. So if you're trying to save space, both of them are going to work the same way, but if you're trying to save space, you should use the image with the minimal tag, and that is what I recommend. So how to use it? The first thing I'll do is to pull the image, and since I already have the image pulled on my system, it's going to show this particular prompt. The next thing to do is to get to the directory which contains the JSON files. Now we are already in the container profiler, and the new JSON test has all these directories. Now the new JSON test, I've also pushed this directory on the main repository on GitHub, so that all of you can also use it to test if the graphing scripts are working properly on your system or not. So what we need to do is just go inside that directory. So here we are. We have all the JSON files inside this, and then we can simply execute this command, which is going to open a container built from the image that we just pulled. And there you go. It's pretty fast. It just fires up a container, and you're supposed to execute these 3 commands. So just copy them and paste them here, and that's going to make the plots for you. And in the end, you can just exit the system. The container is going to shut down, and you're back in the folder where you started. Now in the new JSON test, you'll see you have 2 directories created, the delta JSON and the output. The delta guy is the directory which contains the deltas of all these JSON, and these deltas are then converted to the CSV files, and then the CSV files are plotted using the Python library. And the output directory contains the output plots of all these JSON files. So if you try to see what's inside them, you'll see there is a bunch of PNG files, and they are basically plots generated using the Python libraries. And to get a better visual idea of it, you can go in the new JSON test and see what it's like. So since that new JSON test is a fairly simple stress command, it's just gonna show you this. And if you're seeing this on your computer, it means the graphing libraries are working correctly. So yeah, all these plots are generated for you by the pre-built image, and you can basically use this image for any output directory you have. So you can have your own workflow to benchmark. You can create output directory of the samples which are collected by benchmarking that, and then you can use this image to create a container and plot all the graphs. And this is going to keep the thing simple for you. You will not need to worry about the dependency cycles. So yeah, I hope you have fun plotting your results. Thank you.